algebra students, we're getting ready for Chapter 8, Section 2, where we're going to be learning to multiply a polynomial by a monomial. But first, let's make sure we are comfortable with adding and subtracting polynomials. So pause the video here and try the review, and come back in just a second. We'll check and see how you did. Alright, so don't forget, when you are subtracting polynomials, like in number 2 and again in number 3, you have to distribute that negative sign to everything inside the parentheses. And then the perimeter problem, if we know the total perimeter, you subtract the other two sides to find the third side. So we were subtracting. I tried to highlight that with red. And I was able to check. So I know number 2 is right because I plugged it back in to check it. Okay, so let's talk about today the new part of our lesson, which is multiplying a polynomial by a monomial. You can do it horizontally or vertically. I tend to do it horizontally. So the number one rule for multiplying is distribute. Don't forget that the whole term gets multiplied by 6y. So that's going to start off with 6y times 4y squared. I don't want to forget to add my exponents, so I'm just going to take my time and write everything out, at least until we get the hang of it. Alright, that negative sign stays with the 9y, but 9y is getting multiplied by 6y, so it's a negative 9y. The negative sign stays there, and 6y is getting multiplied times 7. So here 6 times 4 is 24. Y times y squared, we add our exponents. That's an understood 1, so it's 24y to the third minus 6 times 9, which is 54, and then y times y is y squared minus 6y times 7, which gives us 42y. And that would be the result of the product of that monomial times that trinomial, because there was 3 terms in parentheses. Alright, let's tackle number 2, where we have to be careful. Let's give negative 6d to the third power a hug, so we don't forget that the negative is also being distributed to everything inside parentheses. So there's 4 terms in this polynomial. So the negative 6d to the third times positive 3d to the fourth minus, I'm just copying the sign there, negative 6d to the third times 2d to the third minus, because that's the sign in between, negative 6d to the third times d plus negative 6d to the third times 9. Don't let that negative erase. Negative times a positive is going to stay negative 18. Our d to the third adds, the exponents add to d to the fourth, making it d to the seventh. Negative times negative here is going to make a positive. 6 times 2 is 12. D to the third makes d to the sixth. Negative negative is going to make positive. 6 times 1, d makes it 6. So d to the third, d to the ones, d to the fourth. And positive negative is going to give us a negative. And again, 6 times 9 is 54. D to the third. Make sure that your exponent looks like an exponent right here. My 4 was not small enough to look like an exponent. So here is the result of that multiplication. Alright, for a little checkpoint, I want you to check out number 3 and see if you can understand how to distribute the 3x and bring your answer to class tomorrow. Alright, our instructions for this next set of problems simply says to simplify. Well, if we're simplifying, we have to obey whatever operations are involved in this problem. So we're going to need to multiply the 3 times that whole polynomial. Polynomial, it's a mouthful. And then add the product of 6t in the second polynomial. So there's a couple more steps involved in this problem. So the 3 gets distributed. I can do that all at the same time. 3 times 2 is 6t squared minus 3 times 4 is 12t minus 3 times 15, 45, plus 6 times 5 is 30, and t is t squared, and 6 gets multiplied also times the 2, so it makes for 12t. And now we're ready to combine our like terms. So here's a t squared and a t squared, which will make 36t squared. Here's a t, a negative 12t, and a positive 12t, so actually those cancel each other out. And then we have a negative 45 with no other like terms to join it, and that's the simplified answer for number 1. Alright, number 2, again, I'll need to distribute the x, so that makes 3x to the third plus 4x, plus, distribute your 2, 14x minus 6, then go through finding our like terms. There's not another 3x to the third, and again my exponent was too big, need it to be little, still not very little, but it'll work, plus 4 plus 14 makes 18x minus 6. Alright, for a checkpoint I want you to do this last one, the second number 2, which should have been number 3. Check and see how you do with this problem. Don't forget to distribute, and oh, don't forget this negative gets distributed with your 2y also. Moving on to our real world examples where we're at an amusement park. For the first one, it says admission to the Super Fun amusement park is $10. Once in the park, the super rides are an additional $3 each. The regular rides are an additional $2. Yogi goes to the park and he rides 15 rides, of which S of those 15 are super rides, so they're defined in the variable. They want us to use S to stand for super rides. Find the cost if Yogi rode 9 super rides. Okay, I usually have to read my word problems more than once. So admission is $10. Once Yogi gets in, super rides are going to be $3 each. Regular rides are $2 each. Yogi goes to the park and he rides 15 rides. Of the 15, S of those are super rides. So find the cost if Yogi rode 9 super rides. Okay, so here we go. He's going to spend $10 just to get in. Then it's $3 for the super rides plus $2 for the, I'm going to use R for regular rides since they use the word regular right here. So they told us now that we're going to say he rode 9 super rides. So in place of my S, I'm going to plug in 9. And find the cost if Yogi rode 9. So to figure out his total cost, I need to know how many regular rides he rode. Well, it told me a couple of times here that he rode 15 rides. And of those 15, 9 were super rides. So that means out of 15, there's 6 left to be his regular rides, because 9 plus 6 makes 15. And so we started off with a polynomial, but now we've been able to plug in our values for our variables, and now we're ready to add it up. So it's going to be 10 plus 27 plus 12. So Yogi's going to end up spending a total of $49 at the amusement park. Okay, I'm going to let you try this next real world example as a checkpoint for yourselves. Next, as we're talking about multiplying a monomial times a polynomial, What if our situation isn't to simplify, but rather to solve? Here we have equations. What makes it an equation? That equal sign right there. So we're going to apply our multiplying skills, multiplying and polynomial skills, with our solving algebraic equation skills. And it's going to look something like this. I'll take care of each side one at a time. So I'll have 12b plus b squared minus 7. So there's our left side of our equation. The 2b is just hanging out. It's not doing any multiplying yet. Plus, now I need to take care of distributing that b. So it's going to negative 4b plus b squared. Now, so I'm going to take care of each side. There are no like terms on the left side, so I'll just leave it as it is. But on the right hand side I have 2b and negative 4b. So I'll need to take care of that and have negative 2b plus b squared. Now I'm ready to get all my b's to one side and all my numbers without b to the other. Luckily, my b squareds are going to cancel, because when I subtract b squared from either side, it's going to cancel. So I can now add 2b to both sides. So start separating my b. So that's 12b minus 7 equals, actually, those cancel, so 0. So let's add 7 to both sides. So we have 14b equals 7. So we'll divide by 14 to get b, and b is actually going to be 1/2. Okay, I'll do the second one, and then I'm going to leave the third one for you to check your understanding. So I have to multiply. X times x is x squared plus 2x, plus distribute again, plus 2x squared minus 6x plus 7 equals, distribute your 3x squared minus 15x minus 12. Now we're ready to start combining like terms on the left hand side. This was supposed to be an x squared. Sometimes things aren't, my pen's not catching. So it's positive 2x squared. Okay, so we have an x squared and an x squared, which gives us a total of 3x squared. Then I have a 2x and a negative 6x, which makes a negative 4x plus 7. Doesn't have any terms like it. And when I get ready to combine across the equal sign, again the 3x squareds are going to cancel, which is a good thing because we've not talked about how to solve polynomials when the power stays to be x squared and it's an equation. Stay tuned, that's coming up. So now we're going to add 15x to both sides, and I'm also in the same motion going to subtract 7. So now I have 11x equals negative 19. So when we divide by 11, x is going to be negative 19/11, and you can leave it as an improper fraction. Those are just fine. So work this last problem on your own, and be very careful to pay attention to all details of your signs, and don't forget to add your exponents when you're multiplying your variables. And I don't know about y'all, but I'm thinking snow. Have a great day.